Hi there, this video is going to cover the 5-2 warm-up and then the 5-3 notes. So for the 5-2 warm-up, it says just verify the identity. In this section, we're learning to get the left side of our equation to look like the right side of the equation. So if I zoom in on number 1, I get tangent squared theta over secant equals sine theta tangent theta. So because the left side's a little bit more complex, I'm going to focus on that one first. I can try to replace tangent with sine squared theta over cosine squared theta, and then keep that over secant. And then I can actually bring secant to the top of my equation, or to the top of my fraction, and by doing so that becomes cosine. So now I've got cosine theta times sine squared theta over cosine squared theta. Cosine's going to cancel with one of these cosines, and I end up with sine squared over cosine. This can then break apart to become sine theta times sine theta over cosine theta, which can be written as sine theta tangent theta. And that is equal to the other side. Number 2 is 1 over tangent plus 1 over cotangent equals tangent of x plus cotangent of x. So this is one of those situations where it's super easy to use your shortcut. Remember that if you bring these to the numerator, they become the reciprocal functions. So tangent of x becomes cotangent of x, and cotangent of x becomes tangent of x. And then the only thing you have to do is rearrange the order because addition doesn't matter. So tangent of x plus cotangent of x equals tangent of x plus cotangent of x. You could have done this differently. You could have found a like denominator. It worked a little bit more complicated, but in the end, this is definitely the faster way to go. Okay, number 3 says sine t times cosecant of pi over 2 minus t equals tangent of t. Again, the left side's a little bit more complicated, so I'm going to work that left side. This cosecant of pi over 2 minus t is one of your cofunctions. The one that matches that would be secant of t. And then sine is going to stay as sine, but secant becomes 1 over cosine. And then sine times 1 over cosine would be sine over cosine, which is tangent. Okay, that sums up the 5.2 warm-up. Now we're going to talk about the 5.3 notes. So in Chapter 5, Section 3, it's called Solving Trig Equations. So a little bit different from what we've done in the last 2 sections. We're actually combining what we did in 4.7 with our inverse trig functions in with solving equations. So example 1 says to verify that the given value is a solution. So if 2 times cosine of x plus 1 equals 0 is my equation, and x equals 2 pi over 3, then how to verify this is simply take that 2 pi over 3 and plug it into the value for x. So I get 2 cosine 2 pi over 3 plus 1 equals 0. So now I got to use the cosine of 2 pi over 3 first, and goes back to your unit circle. So if you remember, your over 3 is going to be your 1/2 and root 3 over 2 coordinate. And since it's the cosine, we're talking about a half. But at 2 pi over 3, which is in that second quadrant, this 1/2 would be negative. So 2 times negative 1/2 plus 1 becomes negative 1 plus 1, and 0 equals 0. So in my directions, it already said that it was a given solution. This work is simply the proof. But if it had said, is it a solution, then you'd be plugging in and seeing if the left side equals the right. If it does, it's yes. If it doesn't, obviously, it's no. The reason we start with this is because every question from here on out can be checked using this method. So when we're finding an angle, if you're given the function, Remember, this is similar to 4.7. You're going to locate the solution on your unit circle. So it's going to say sine of x equals something, or cosine of x equals something, or tangent of x equals something. You're finding that coordinate point on your unit circle, and then list the angles that match up with that coordinate point. So the difference this time is that on our typical interval, we are going to restrict it differently. These are not inverses, so we don't have to restrict it so that it passes my horizontal line test. I simply take what's on my original unit circle, and for sine and cosine, it's going to happen every 2 pi. So whatever answer I get for those, something like maybe pi over 3, if that's an answer, I'm going to add 2k pi. And what this is telling you is that your answer is going to occur not only at pi over 3, but it's going to occur at every 2 pi after pi over 3, because these points are cyclic, if you remember. So that's the case for both sine and cosine. We add 2k pi. K just represents a constant. 1, 2, 3, -1, -2, all of those things. But you'll keep it as k. For tangent, we add k pi because it's going to happen here and it's also going to happen here. So it happens every half circle. So if it was, again, pi over 3, for tangent, I would say plus k pi. Unless it's restricted on an interval. So in the case like this, if it said it is restricted from 0 to 2 pi, then you are keeping it from 0 to 2 pi. And only that. You don't have to add on the 2k pi. If it says tangent, it will most likely restrict it to negative pi over 2 to positive pi over 2. And then if it's restricted within that interval, you don't add the k pi. If it's not, you always want to add the k pi. Okay, so it says solve. These are already solved. Your trig function's already isolated. We just need to locate the points on your unit circle. So I'm going to pull in a unit circle. Here's my unit circle again. So for A, it says sine of theta is 1/2. So what this is, because this is sine, we're saying where is y a positive 1/2? And as you look around your circle, your y is positive 1/2 here, and your y is positive 1/2 here. The other two locations would be negative 1/2. So the first part of my answer is pi over 6 and 5 pi over 6. And then because it didn't restrict the interval here, we're saying this is plus 2k pi. This is going to happen at pi over 6, and then every other coterminal angle to pi over 6, and 5 pi over 6 and every coterminal angle to 5 pi over 6. Now let's look at B. So B says cosine of theta is negative root 3 over 2. Now we're talking cosine, which is going to be the x value, and we want it to be negative root 3 over 2. So as you look around your unit circle, cosine, or the x, is negative root 3 over 2. Over here again at 5 pi over 6, and then down here at 7 pi over 6. So my two angles are 5 pi over 6 and 7 pi over 6. And then to these, I add 2k pi for each one. And then this last one is tangent. So tangent is your y over your x. If you remember, we said the shortcut for tangent is if it's an over 6, it's root 3 over 3. If it's over 4, it's 1. And if it's over 3, it's root 3. At 0, it's 0. And at pi over 2, it's undefined. And then that pattern carries around your circle, obviously the sign changing positive, negative. So the first time we see a negative 1 would be over here at 3 pi over 4. And then you'll also see it down here at 7 pi over 4. But if you remember, the interval for tangent is just k pi instead of 2k pi. That means that onto that first one, I'm already adding a half, which gives you the second one, and then it would just keep repeating that way. So you don't need to add 7 pi over 4 plus k pi. You can keep it as 3 pi over 4 plus k pi, and it will, by adding on that k pi interval. If my interval was set at, let's say it was 0 to 2 pi, I don't have a bracket here, then I would include both of those as my answer. So only the ones that are on your regular unit circle. Okay, so now we just take it a step further. Now we've got to solve the equation first and then isolate the trig function and then do what we just did. So we're going to isolate the trig function just like you would if it was a normal x, and then use the unit circle to find when x equals that number, or when the sine equals that number, the cosine equals that number, the tangent equals that number, whatever the trig function is. Example 3. So there's 3 different examples underneath this, but they all say solve the equation. So I start with this. A is 4 sine squared x minus 2. If I wanted to solve for sine squared x, I'm going to first add the 2. So I get 4 sine squared x equals 2. Divide both sides by 4. I get sine squared x equals 1/2. And then to square root both sides of the equation, because I have to get rid of that sign, I'm going to square root it, but I'm going to remember to put the plus and minus on the right-hand side of my equation. So now I get sine of x equals plus and minus the square root of 1/2, which is square root 1 over square root 2. This becomes 1 over root 2, which gets rationalized to root 2 over 2. So based on that, I'm looking for where the sign is plus and minus the square root of 2 over 2. As you move around your unit circle, hopefully you would realize that that is at every over 4. So it's going to be at pi over 4. It's going to be at 3 pi over 4. It's going to be at 5 pi over 4. And it's going to be at 7 pi over 4. And again, my instructions did not restrict my domain. So to all of these, I would add 2k pi. And if I wanted to check these, I could take them individually and plug them in to check them. All right, B, sine squared x minus sine x equals 0. So hopefully this time you realize there's a squared and a to the first power, which means I'm going to factor. I can take out the sine. So I'd get sine of x minus 1. And then if either of those terms equals 0, then the entire thing equals 0. So I can split it and say sine of x equals 0 and sine of x minus 1 equals 0. Solve the right side and I get sine of x equals 1. So now I'm looking for 2 answers. One in which sine or my y is 0 and one in which sine or my y is 1. I'm going to pull back in that unit circle so we can see it again. So again, looking at your unit circle, you're looking for the y, where the y is 0, which happens here at 0 and here at pi. So I'm going to say 0 and I'm going to say pi. And then I'm looking for where the y is positive 1, which is up here at pi over 2. And then to each of these, I would add 2k pi. And this last one, C, says 3 tangent squared of theta minus 1 equals 0. I want to work to get theta, tangent squared theta on the side by itself. So the first thing I'm going to do is add the 1. 3 tangent squared theta equals 1. Divide both sides by 3. And then I square root both sides, making sure I put the plus and minus on the right-hand side. And I get tangent of theta equals plus and minus the square root of 1, which is 1, over the square root of 3, which is going to get rationalized to root 3 over 3. So I'm looking for where tangent is both positive and negative root 3 over 3. Hopefully you remember that's going to happen at all your over 6s. So it's going to happen here, 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 and here. Because this is tangent and you're adding on k pi, you only have to use the first 2 and then it will automatically add in the last 2. So if I started with pi over 6 and added k pi, it's going to put you at the other half of your circle. If I did 5 pi over 6 and added k pi, it's going to go from here to the other side, taking care of those other 2. And then it's going to repeat every half circle around. If you add in those other those other two, so if you did pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 plus k pi, I'm not going to mark it wrong. You're just adding in angles that are duplicates, but that's totally fine. All right, let's look at some more examples. So this is example 2. Actually, it says 2, but this should be example 3 continued. And D says 3 cosecant squared x minus 4 equals 0. So this is our first inverse function, or our first reciprocal function. What we need to do is the same thing we're doing before, isolate that function, and then at the very end, before we find it on the unit circle, flip it. So I'm going to add the 4. I get 3 cosecant squared x equals 4. Divide both sides by 3. So cosecant squared x equals 4 over 3. Square root both sides of the equation, putting a plus and minus on the right-hand side. Cosecant x equals the square root of 4, which is 2, over the square root of 3, which gets rationalized. Actually, I don't need to rationalize it. If you rationalize it and then flip it, you're going to have to rationalize it again. So at this point, you want to say if its cosecant is 2 over root 3, then the reciprocal, which is sine, is plus or minus root 3 over 2. And again, going around your unit circle, you can look at yours if you need it, but hopefully you remember that this is saying where is y, root 3 over 2, and that's at every over 3 on your circle. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then because it didn't restrict my domain again, to each of these I would add 2k pi. All right, E says 2 cosine squared x plus cosine x minus 1 equals 0. So this is the first one we've had a factor when there's 3 terms. Remember, if you want to replace them, you could take out the cosine and replace it with something like a, and this would be 2a squared plus a minus 1 equals 0. Or you could factor it straight from the beginning. So this would be 2 cosine of x and cosine of x. And then I'd be looking for the factors of negative 1. That when multiplied by that 2 is going to give me a positive 1. So if I did negative 1 and positive 1, this is negative 2 plus 1, which would give me a middle term of negative 1. So that doesn't work. I need to switch the signs. Make this a plus 1, this a negative 1. That way I get a positive 2x, or positive 2 cosine x minus 1 cosine x, which would give me a positive cosine x. So now that I know that's the combination that works, I would split this and set them both equal to 0. And add the 1 on the left here, so 2 cosine x equals 1, and cosine x equals 1/2. And on the right, cosine x would equal negative 1. So now I'd want to go around the unit circle and identify where the x is 1/2, positive 1/2, and negative 1. So x is 1/2 at your over 3s, and it's going to be positive at pi over 3 and at 5 pi over 3. And then cosine is negative 1, or your x is negative 1 at pi. And then to each of these, you're going to add 2k pi. So the quicker you can reference the unit circle, the easier these are going to become. All right, F. F says 2 sine squared x equals 2 plus cosine x. So this is the first one we've had in which we have 2 different trig functions. We need to change it so that it has the same trig function. So this is where we pull back in our trig identities from 5(1) and 5(2). I can't change cosine to be anything dealing with sine if it's raised to the first power, but I can rearrange my Pythagorean identity that has sine squared and cosine squared to replace sine squared. So if you remember, our trig identity says sine squared plus cosine squared equals 1. So if I wanted to isolate sine, then I can say that sine squared x equals 1 minus cosine squared x. And now I can take what sine squared x equals and plug it into the place of sine squared. So this becomes 2 times 1 minus cosine squared x equals 2 plus cosine x. Now I have a single trig function, just cosine, and I can continue to work this out. Distribute that 2. I get 2 minus 2 cosine squared x equals 2 plus cosine x. Hopefully, once you see that there's a squared and a raised to the first power, it's your hint that you're going to have to get everything to one side and factor it out. Because this is negative, I'm actually going to move everything to the right side. So subtract the 2 and add the 2 cosine squared x. And I get 0 equals 2 minus 2 cancels. And I get cosine of x plus 2 cosine squared x. Now there's two terms, one squared and one is not, but they both have a cosine on them. So I can factor out the cosine. And I get 1 plus 2 cosine x. Now if either of these are 0, the whole thing's 0, so I can split it and solve it. On the left, I get cosine of x equals 0, and on the right, 2 cosine of x would equal negative 1. Cosine of x would equal negative 1/2. So again, I'm looking cosine. This is my x coordinate. Where is my x value? 0. Two places, one at pi over 2 and one at 3 pi over 2. Where is my x value? Negative 1/2. Also two places, 2 pi over 3 and 4 pi over 3. And to each of these, we're adding 2k pi. All right, an example, and this should be now example 4, the directions change. It says find all the solutions in the interval 0 to 2 pi algebraically, and then use the table feature of the graphing utility to check your answers numerically. So let's start with the first part. Find all the solutions in the interval of 0 to 2 pi. This is the first time we've been restricted to 0 to 2 pi, which means we are only looking at our unit circle. We're not adding on any of the intervals. So I'm going to look at this equation, secant squared x minus secant x equals 2. Again, I see that there's a squared and a non-squared, so that's my hint I'm going to factor. I'm going to get everything to one side by adding or subtracting the 2 from the left and the right, and I get secant squared x minus secant x minus 2 equals 0. I'm going to factor this out. So secant x times secant x would be secant x, or secant squared x. And then I have negative 2. So one's got to be negative 2, one's got to be positive 2. And it doesn't matter which one, because if I multiply these out, either way I'm going to get the negative 1 secant x for my middle term. Now if either of these are 0, the whole equation is 0, so I set them each equal to 0 and solve it. This is secant of x equals positive 2, and secant of x equals negative 1. Now secant is not on my unit circle, but its reciprocal, which is cosine, is. So I'm going to rewrite as the reciprocal and then flip 2 over 1 becomes 1 over 2. Rewrite so it's the reciprocal, flip negative 1 and it's still negative 1. So I'm going to pull in my unit circle one more time. And this time we are only looking at the values on my initial unit circle. So I'm looking for where cosine is a positive 1/2, where my x is a positive 1/2, which is going to be pi over 3 and 5 pi over 3. And where my x or my cosine is negative 1, which is just a pi. And then because it said to only keep it within those ranges, those would be my answers. Pi over 3, 5 pi over 3, and pi. We're actually going to stop there because, one, you're not going to have your graphing calculator, so you won't be able to use that table feature to figure out your answers. If you wanted to check them using your calculator, you could plug these values back in. Just make sure your calculator is in radians. But again, you wouldn't have that on your test, so don't get used to that. The other thing is pay attention on your homework because it might indicate what to use as your constant. So it might actually say to use, some of the questions might use n instead of k. So if my answer was pi over 3 and it said to use n as your constant, then instead of writing k pi, I would change it so that it's pi over 3 plus 2n pi. So again, this is just a constant that represents a constant. If the questions on web assignment say use n, then use n. And then also look for a restriction for degrees. So if it said instead of 0 to 2 pi, it says 0 to 360. Now you're finding these angles in degrees. So if it was pi over 3, it'd really be 60 degrees. Just make sure you read your instructions carefully. Use the rest of the class period to work on that assignment, and then we'll finish the notes for 5-3 tomorrow. Have a great day.